Start.
Okay, this is the Vapour Compressor Air Conditioning Test Strip. The aim of the experiment is to find the top for the open cycle. Here we have two cycle operations. One is open cycle, the other one is closed cycle. For the open cycle, we will be letting this out. For the closed cycle, we will be doing pushing the duct inside this. And we have one more condition which we need to follow. For open cycle, we have to bring this here, and for the closed cycle, just we can do like this. This is first we need to do the open cycle. Let us do this. So first and the foremost thing, we have to switch on the mains. As we switch on, we have to start the MCB. Once we do that, allow it to reach a steady state. So as and when it reaches the steady state, we should start taking the readings. What are all the readings we will be taking? We will be taking the temperatures. So here is the temperature in that. What are all the readings we will be taking? Is P1 and P2. That is compound pressure and pressure gauge pressure. P1 and P2. Outside reading has to be considered. So it has to be somewhere around 50. It reaches 55. We need to wait almost around, yes, it is almost around 55, and this is 200 and plus. So we will be taking the different temperatures. That is T1 happens to be the inlet to the compressor. T2 it's outlet to the compressor, outlet from the compressor. Then T3 happens to be the outlet from the condenser. That means T2, which is the outlet from the compressor, goes to the condenser. Then T3 it is an outlet from the condenser. T4 it is the temperature after the expansion which we take. T5 it is a temperature at the outlet of the duct, that happens to be the air outlet duct, and from this temperature what we are getting, we take that as a T5. And T6 happens to be the temperature before evaporation, and T7 it is the temperature after evaporation. How do we find the temperatures? This is the temperature indicator. We need to press this T1. Increment just one press, it gives an increment T2, one press T3, T4, T5, and T6. How do we do? We take this. Here is the knob. If you check this, this is in T6. If you see this, it gives no connectivity. So let's decrement this. This is the temperature T6, and it is indicated here 28.6. Okay, this is relative humidity in percentage, and this is the temperature. If I set the knob towards the upside, then we get the T7, which is 26.45, whatever it is reading. So I am repeating again, how do we get the temperatures? Say first T1, then just an increment button, T2, T3, T4, T5. T6 happens to be with this knob and downside, and here we need to note the temperature. T7 it is knob upside with the temperature on this humidity after cooling box. Above that we have relative humidity. We need to note on the voltmeter reading as well as the ammeter reading. Yes, then we have energy meter. We have to use the stopwatch and get the time. For each pulses, we need to count the time for 10 pulses. For 10 pulses, what is the time taken? If I see this red, start taking the time, and count for 10. It will be 10 pulses. Here you can find the outlet velocity of the air which is coming out. Since this is the open cycle, we will get the velocity of the air here outside. We need to take the average of this velocity. So first position here, second position this, third position is here, and fourth position is here. On an average, whatever I get, I take this as the velocity. This velocity is taken by the anemometer. And using this anemometer, we will be finding the velocity. Now we will look at the calculation part. Average velocity, what does velocity of the air is equal to 4.4 meter per second. This is the voltmeter reading 299 volts, ammeter reading 4.76 amps. Then this is the time taken for 10 blinks, okay, which is 11 seconds. These are the temperatures T1, T2, T3, T4, T5, T6, T7. Okay. Then the pressure, first pressure in PSI, then converted to bar, second pressure, then converted to bar. We need the pressures in bar. Now the experimental curve. How do we get the? We need to find the relative curve of this open cycle process. So before that, we need to find what is experimental curve. Then followed by experimental curve is nothing but actual curve, and followed by the theoretical curve. Then we get the relative. So work done by the compressor is given by mass of air into Cp. Cp is the specific heat of the air into temperature difference. The temperature difference is T5 minus T7. So mass of air, we know that it is velocity into the area of the duct into the density. So velocity is 4.4 into area of the duct is 0.12 meter square. It's given, the data is given, into its the density of the air is taken as 1.25. So if I substitute in this, the Cp of the air has to be noted down. The Cp of the air is 0.12. If I substitute this things, Cp of the air is 1.001. If I substitute in this, we get the WC as 2.8. Now this IPC is given by N. This is the number of impulses per cycle. This is the number of impulses. 10 impulses what we have taken into 3600 by EMC. What is this EMC? EMC is into 3600. That is number of impulses into 3600 by energy meter constant into the time taken for this impulses. This is the efficiency, electromechanical efficiency of this we take. So 10 into 3600 by this energy meter constant has been given. So we take 3200 has been given. 3200 into the time taken for completing 10 plates is 11 seconds. So divided by 11 into the efficiency, electromechanical efficiency is considered as 0.7, 70% efficient it is. So we get the answer as 0.7159. Okay, once this is done, curve is given by WC, that is WC by the IPC. So we have 2.8 by 0.7159, which is considered as, which is obtained as 3.92. This is the experimental curve. Next is theoretical curve. How do we get this theoretical curve? This the refrigerant used is Freon 22 or Freon 22 from the chart, that is pressure enthalpy chart. We need to pH chart. We need to get the values of H1, H2, H3 and H4. At what point we can get H1 is P1 comma T1. The first pressure P1, that means 0.37 bar, and T1 25.8. The H1 is obtained, and the obtained H1 will be 430. Its enthalpy is equal to 430 minus, then H2 will be in a similar way, P2, T2, and H4 here we have P1 is equal to P1 and T4. This H4 is obtained at the condition P1 and T4. This P1, T1, and whereas this is at H2 is at P2 and T2. These are all the points at which the enthalpies are obtained. Once I calculate this, substitute and calculate, I get the theoretical curve as 9.3. And the relative curve is given by the actual curve by the theoretical curve. Relative curve, we define the ratio as ratio of actual curve by theoretical curve. So actual curve, we have got it as 3.92. That is nothing but the experimental curve. Over theoretically, what we have done using this chart and all, we get 9.33. So if I divide this, I get 0.2. So the relative curve is 0.42. So this is all about the open cycle process.